In this segment, we're going to continue working with fractions, and we're going to talk about the relationships between mixed fractions and improper fractions, and using the manipulatives to help students see those connections a little bit better and how to switch back and forth between the two. We're also going to introduce a little bit about how the symbols indicate the meanings of mixed fractions and improper fractions. So just taking a second to make sure we understand our definitions, a proper fraction can be defined as a fraction that represents something that's less than a whole, and it's characterized by having a numerator value that is less than the denominator value. So if that is my whole, then I take a piece of that whole, and I might be able to write that as a fraction called 1/2. I have two equal regions, and one of them is shaded in red, so I have 1/2, and that would be a proper fraction. An improper fraction is a fraction that's representing either a whole or something that's greater than a whole, and it's characterized by having a numerator value that is equal to or greater than the denominator value. So if I had something like this, there's one, there's another, that would be an improper fraction, because now I have two pieces of equal size, and that's going to be the same as a whole, and that would make it an improper fraction. So 2/2 would be an improper fraction, because that's going to give us a whole. If we had an extra piece now that's going to definitely be an improper fraction, because now we have something greater than a whole. We have one whole plus some extra piece. We're going to have an improper fraction, and it would be written as 3/2. And that would be also an improper fraction. So if our numerator is equal to or greater than my denominator, that indicates that I have something bigger than a whole already, and that would make it an improper fraction. And a mixed fraction would be mixed because it has a whole number and it's mixed with a proper fraction. So the whole number and the proper fraction are mixed together, and that's what produces a mixed fraction. So 3.5 would be an example of a mixed fraction. And visually I'd have 3 wholes and 1/2. So I have some wholes and a proper fraction, so that would be a mixed fraction. And if we had 2 and 3/2, that would still be called a mixed fraction, but it wouldn't be acceptable, because not only do we have a whole number and a fraction, we have a whole number and an improper fraction, and we'd have to fix that 3/2, which is 3/2, into a whole. So therefore we would have 1 whole, 2 wholes, 3 wholes, and 1/2. So if we wanted to fix this into a correct version of a mixed fraction, it would be 3 and 1/2. So we have to make sure that we have a whole number and a proper fraction, not a whole number and an improper fraction. Now if I think of my fraction 1/2 as being I have one whole, and I have to divide it into 2 equal sized pieces. And so there's the 2 pieces, one piece that's going to look something like that, and the other piece would look something like this. They're 2 equal sized pieces, and I would only have one of them, so I'll get rid of this one. Then I would say that this would be, the red would be 1/2 of my whole. My fraction of 2/2 would indicate that I have 2 of these 1/2 pieces, which would make one whole, and now if the top one was a proper fraction, this would be classified as an improper fraction. And in this configuration I have 3 halves, and so we can see that that's enough to make one whole. There's my whole plus 1/2, and so we would write this as 1.5. And we want to make sure that students understand that you can write the fractions either as a mixed fraction or as an improper fraction. Sometimes in some operations it's better to work as a mixed fraction, sometimes it's better to work as an improper fraction, but in the real world often we very rarely ever say I want 3 halves. We would usually say I want 1.5 inches of something or 1.5 feet. We wouldn't say 3/2 of a foot. So it's a little bit more common to be able to switch them into a mixed fraction, and it's important that we know how to do that. Continuing on. In the first segment on fractions, I talked about an alternative way of thinking about fractions. Instead of saying a parts of a whole, we could say that this first number, this 1 number, talks about how many wholes I have. So I have 1 whole, and I want to cut it into 2 equal parts. So there's my 2 equal parts. There's one there, and here's another one there. So any one of those could be classified as 1/2. So I'll take this one away, and we could call this red one 1/2. Nothing particularly new there. On this next one we have 2 halves. So this is where it starts to get a little different. The top number tells me how many holes I have. I have 1 holes and 2 holes, and I want to cut it into 2 equal size pieces. So if I wanted to cut it into 2 equal size pieces, there would be one of the pieces, and there would be the other piece. And so each piece, if I want to have 2 holes cut into 2 pieces, each piece would be called 1 hole. And in this 3/2 example, I have 3 whole circles and I want to cut it into 2 pieces. Well, I can cut these ones into 2 pieces. That's pretty simple. But then I have this one piece that's left over and I have to cut that into 2 pieces. So if I cut that into one piece that looks like that and one piece looks like that, then my question says, if I have 3 holes and I cut it into 2 pieces, what does each piece look like? Well, one piece would have a hole in it as well as a half. I'll put that up here. And this one would have a hole as well as a half. So each piece would have 1 1/2. So 3 over 2 could equal 1 1/2 using this idea as well. Either way, we get 1 1/2 on our left-hand side and 1 1/2 on our right-hand side. This one has to take a look at all the different pieces and stacking them together to make holes. And this one takes holes and divides it into pieces. And this confirms or reaffirms that fraction meaning as division. So 3 divided by 2, this diagram over here on the right-hand side flows a little bit better with that idea. So just with another example, here I have the idea of 5 halves, 1, 2, 3, 4, 5 halves, and I have enough here to make 1 hole. I have enough here to make another 1 hole, and I have here enough to make 1/2. So I put those together, and I add those together, and I get the answer of 2 1/2. And on the right here, I take my 5 holes, and I divide it into 2 sections. There's section number 1. Here's section number 2. And I have this piece I have to cut into 2 pieces, so I'm going to cut that into 2 pieces. And color them in red. And so if I take my 5 and I divide it by 2, each piece is going to have 1 2 1/2, and this piece would have 1 2 1/2. So 5 divided by 2 would be 2 1/2. So I get 2 1/2 in either direction, whichever technique I want to use. This one is more of the division technique, and this one's more of the repeated subtraction technique. In both cases, my question is 5 divided by 2, and when I go 5 divided by 2, I get 2 with a remainder of 1. Here I have my 2, 1, 2, and my remainder of 1, 1 what? Remember that I'm dividing by 2, or halves, so I have 1/2, 2 1/2. Here I'm dividing by 2, and I have 1/2 left over, 2 and remainder of 1, 1 what? 1/2, 2 remainder 1 is 2 1/2. Both cases talk about dividing my fraction. Up to now, our examples have been starting off with improper fractions and changing to mixed. So here we're going to go with a mixed fraction, change it to an improper. So working with the pattern blocks, there's my 3 holes plus 1/2, gives me my 3 1/2. I can also write my 3 this way though, with 2 halves together to make 1 hole, 2 halves to make 1 hole, 2 halves to make 1 hole, 3/3 to make 1 hole, 3/3 to make 1 hole, 3/3 to make 1 hole, and then I still have my halves. So there's my 3s and a halves, and they can be rewritten this way. So I could put the first one together, and that gives me 3 1/2, which is my mixed fraction. This one together gives me 6 halves plus 1/2, for a total of 7 halves. And the third one gives me 9/3 plus 1/2, but I can't really put those together because they're not the same shapes. So if this is my mixed fraction, this is my improper fraction. This one I have to do some more steps before I can work with it. So what we want the students to understand is one of the ways of thinking about changing a mixed to an improper is to make sure that all the shapes are the same kinds of shapes, and we have them in a total. So I have a total of 7 of these 1/2 shapes. I can't do anything with this because I don't have all the same kind of shape yet. We often show our students this shortcut, the 3 times 2, and then we add the 1 on the top. And we want to make sure that students understand where that comes from. Well, here's our 3 holes, and we're talking about shapes which are 1/2, which are the red trapezoids, and I've got 3 sets of those. So there's one set of 2, there's another set of 2, and here's another set of 2. And so I now have 3 sets of 2, and that's where that 3 times 2 comes from. And then I have to add on this 1 that I have hanging out over here. So there's my plus 1/2, giving me a total of 7 halves. And going back from 7 halves, if I want to go 7 divided by 2, here's one set of 2 over 2's. So if I take that away, that's going to give me 5 over 2. 5 over 2, take away another set of 2 over 2's, is now going to leave me 3 over 2. And 3 over 2, take away another set of 2 over 2, is going to leave me 1 over 2. So what I'm going to end up with is I took one set of 2 over 2's, another set, and another set. There's my 3 wholes, and I have one set of half left over. So I get my answer of 3.5 going in the other direction. If I want to demonstrate this with the Cuisenaire rods instead of the pattern blocks, if my whole is a red, then my white is 1/2 of that, because it takes 2 of those to make a red. And we see that there. So I could write 7 halves as 7 whites. And if I have 7 whites, then that's going to indicate that I'm going to have 1, 2, 3 wholes, plus 1/2 left over. So 7 halves can equal 3 1/2. Conversely, if I started off with my 3 1/2, 1, 2, 3 1/2, each one of these reds is going to take 2. So there's 2. There's another 2, there's another 2, there's our 3 times 2 concept that we talked about before. That gives me 6, plus my half gives me 7 halves, and it works in both directions. And finally, we want to show something that doesn't have any remainders, and it still works with our division. 9/3. If my whole is a green, it takes 3 whites to make a green, so each white is now going to be called 1/3. So there's my 9/3, and again I would show that for every one of the 3/3 I have, I can make one whole. And so therefore I would have 3 wholes. So 9/3 is equal to 3 wholes. Just as 9 divided by 3 equals 3. So just making the connection again that with our fractions, fractions also have the meaning of division. So in this segment we've talked about going from mixed to improper and improper to mixed. I hope you've seen the importance of using manipulatives to make it visual for the students where the numbers come from. And when we talk about our shortcuts along with the manipulatives, you want to have them working side by side so they can see where those shortcuts come from when we're working with our manipulatives and why the shortcut works and how it works.